Good morning, guys. Can you hear me?
Yes.
Yes.
Good. So it's Friday, October 2nd. So we're in October already. And I'm going to start with a new chapter. I'm going to start talking about enzymes, chapter 6. So we just had our first test, right? So for most of you, it went pretty well. Some of you had some technical issues, which I think we all resolved by now. So I know some of you also mentioned to me that you struggled a bit with the format. I understand that, but you also have to realize that this is I have to have a way to control to proctor it in a certain way, right? So I cannot really be there with you watching you guys take the exam, right? So I have to take measures so that to reduce the temptation for you guys to to use the textbook or to use the Google or something. And I have tried to achieve that using a number of tools, as you may have noticed. So so one of them was I thought I gave you just the right number of questions for the amount of time, so that you would have enough time to answer the questions, but not enough time to start Googling. But some of you still thought that, well, I know that some of you would need a little bit more time. And basically what I did, actually, I followed how you guys submitted the exams. I followed the timing. And indeed that most of you actually used up the entire 55 minutes. So, which is different from what I've usually seen. Usually when I give a test in an in-person environment, half of the class would submit their test before the time is over, right? And so this time that didn't happen. This time most of you did take the entire amount of time, which tells me that actually you did work on the test, and you actually perhaps you did need more time. So I'll take this into account. I mean, I gave you some extra points just to compensate for it, but I will also take this into account when we go to exam 2 and 3 and the final. So that was one way for me to reduce the cheating. Another way was to obviously to try to come up with questions that could not be easily Googled, right? So in other words, these were not quiz type questions. Most of the questions were for you to kind of to think about them, right? So for example, I would ask you, which amino acid would elute first from the column, right? So this is something they cannot Google. Or I ask you, what's the overall charge of a peptide, for example, right? Or I would give you a gel electrophoresis chromatogram and ask you some questions about that. Something that you cannot Google. So some of you refer to these as tricky questions. I don't know. I don't know if that's what you meant by saying the questions were tricky. I don't know, but I think in general, professors should use questions like that on our exams, regardless of the format, because after all, we're not trying to memorize things. If you memorize things, this kind of knowledge will disappear, right? A year or two from now, if you've taken a class and you try to memorize everything, and that's how you took your tests and got the good grade based on memorization, you may have gotten a good grade, but a couple of years from now, you will forget most of the stuff, right? And the best knowledge that you can get from this class is actually gain the knowledge and then apply it. And then it's in the process of the application of the knowledge, that's when you learn the best. So I thought that here I could kill the two birds with one stone, and so reduce the amount of cheating and also just use the right kind of questions. So that's another way. And obviously the format, you guys, and I know you, some of you said that you like to go back to the questions that you answered already. Well, yeah, so I understand that, but that unfortunately doesn't help the cause, right? So if, I mean, just think of a scenario where some students may just get together in groups, right? I don't know. I have no way of knowing, right? You're somewhere there. I'm here at home or in my office. I'm not seeing you. So some students may get together in groups, and if there's all the questions are available to you, you can just, some of you can freely exchange the answers. So which is going to hurt those students who will not do that, right? So it's my goal to protect those students. So anyway, so these are some general ideas, some general considerations that I utilized when I made the test. So if you have any comments or any general questions or comments, just let me know. If you have any comments right now, you want to say something?
In terms of like you preventing cheating, I understand, I do. However, I don't know if that's the most effective way to deter it, because it's just kind of like you prohibiting students from going back to check an answer to make sure that they answered it right. When, like you said, like forming groups, they can do that during the test. It's just kind of like, it's not really the most effective way. I mean, hopefully we won't. It's COVID times, but you see what I mean a little bit?
No. So if you have a question, so for example, so each person has a question and the order is totally different, right? So you have your own set of questions and your last question may be somebody else's first question and you only have 55 minutes. So there's no way for you, I mean, it just stops the communication between students. Because there's no way the students can communicate and exchange the answers.
Oh, well, that's pretty effective to me. It's just kind of like I wish I could go back and check my answer, because I feel like the time rush. I'm like, okay, got to answer, and I don't know if it's right. I couldn't say, okay, now that I've taken the test, let me go back and double check my answers. I feel like that would be more fair, especially because you change the order for each student. That should be enough in itself. Because no student's gonna sit here and say, okay, your question 1 is my question 10. Let's wait. You know what I mean?
I don't know. With 30 questions, it's not so easy to keep track of all of that. As I said, there'll be fewer questions on the next test, but I still don't know what you mean. So you're saying that it's better to have all the questions in front of you, so you can go back and change your answers?
Yes, because that's more realistic. Like in a regular class time, you would have a test packet. You would answer all your questions, and then you would go back and check your answers. Like, I understand what you're saying. Like, it does look like it could be a form of cheating, but that's a typical test usually, to go back and be able to check your answers.
Yeah. Well, let me tell you something. So so the average on this was a bit lower than I expected. I raised it a bit, but I do expect that now that you know what to expect on the next text test, and plus with the fewer questions, I do expect the average to go up. But just to let you know that, for example, when we switched to online teaching at the end of the spring semester, I was teaching organic chemistry. I was teaching organic chemistry 1, OChem 1. And I guess, so there was first we started in class, it was in person, and the averages were about 65 per test. And when we went to online, and I had what you were saying, my exams were such that the students could see all the answers. Guess what the average was?
Higher, of course.
90.
Like, what
Over
teaching?
90, over 90.
Oh my gosh.
It went from 65 to over 90. So I have a way to, I mean, I need to find a way to stop that. And
Definitely.
so if it's over 90, so the remaining 10 are those students who did not cheat, right? And guess how they felt when most of the class cheated and got an A in the class, and they got a C because they didn't cheat. That's just not fair.
Definitely. Like, I understand that. And also, Brianna said that, and I agree with her. It is hard to manage time, ensure we're confident with the answers that we're putting down, and say, okay, this is it. Like, once I answer this question, this is it. So it's kind of like that pressure, along with, like, I understand what you're saying. And we, like, honestly, we have to probably brainstorm more to figure out what's the best way to format a test to prevent cheating.
Yeah.
Because it's just unfortunate in these times. It's like you can't truly 100% prevent it at home, online. It wish we could, but we really can't. So we just kind of have to find the best way that's more accessible to all students and more realistic testing format. But
Yeah, and also the type of questions the level of the questions, in other words, the level of the difficulty. I also that's another way I can actually help you out, guys. So obviously you saw there was very little math on this test. Normally there's much more math, and I try to avoid math questions because they do take time. I think there are only a couple, right? A couple of questions with math, very simple math.
yeah.
Also keep in mind that there will be a way, I promised you there'll be extra credit. And even though right now I kind of struggle with Canvas and finding a way to add extra credit problems into your tests, Saplan is not the most user-friendly platform for teachers. I don't know about students, but for students too, I guess. So I will later during the semester, maybe closer to the end, I will give you some opportunities for extra credit. Okay.
That'll be greatly helpful.
Yeah. So what the grade that you have now, keep in mind that you can still improve on that in a variety of ways. One is as I said, I will give you extra credit problems. Secondly, don't forget that you still have the opportunity to drop any exam scores. If you show up to every exam, right, you don't miss any exam, you'll still have the opportunity to do well in the final and get your lowest score replaced by the grade that you get in the final. So if you did exceptionally poorly on this test, nothing is lost, right? Just study better for the final, and we will replace this grade. So that's another opportunity. There was something else. Let me think. It'll come back to me. There was something else.
I have a question. So
Yeah.
when you said that the grade has to be higher, like the final grade has to be higher, does it need to be higher than the original grade, or the original grade with the 8 points on added? Does that make sense?
Well, so both of them. So yeah, I'm usually pretty generous when it comes to that. When I say the grade that you get in the final itself may be curved as well. So after I apply the curve on the final, that's the grade that I'm going to use. And so the original test will also be the grade on the test plus including the additional points, so that we do compare, you know, the oranges with oranges,
Okay, thank
apples
you.
with apples, right? So the final plus the curve and the original test plus the curve.
That makes sense.
Mm-hmm.
I think you should look at the chat. Like we're having a discussion kind of about like what we think about having more or less problems. So I think the chat be a good place for you to look too. I don't know if you're looking at it.
I've been well, only the last couple of days I haven't looked at the chat because I've been really busy with dealing with all the after exam, the consequences, you know,
The
after
Zoom
after
chat.
exam issues. But normally I go to chat. You mean like a discussion?
The Zoom chat, like the one on Zoom right now.
Oh, there are some questions there.
Yeah, like we're just kind of like discussing like the pros and cons of having less questions, more questions. Kind of like that you like read it and get your input on it too.
I think 30 questions is good. I think maybe if they had more, maybe if we had more time, they had more time, people feel more comfortable. Because, you know, if you have less questions, each question weighs more. And that means if you get one wrong, someone worth 3 or 4 points. If you get one wrong, he brings it down to 20, you know, they could be worth like 5 points a pop or more.
Well, I was
And
thinking, Devin, I was thinking maybe 25 questions with 4 points each.
okay.
I honestly didn't think the 30 questions was bad either.
Yeah, I thought it was good.
I honestly feel like if you know the material, 30 questions in 55 minutes was fine.
I agree.
Well, shall we vote?
I don't think we should vote at all.
Like I understand, like it is true. Like Devin, not David. I'm sorry, had a really
I get it all the time.
point. Like had a really good point about less questions will make it make it way more. And I think was it Rebecca or who first said it?
It was Rebecca.
It was Rebecca. Like she had a point too that we like you have like test anxiety, like that's normal. Everyone second guesses herself on a test, especially when it's like this is like it. I can't go back to it. So it is true. I think more time, like let's say you open it up earlier for people who want to take it earlier, maybe. Like that, and that can give people more time. Like let's say, like I know in another class of mine, she opened up the test at 8:30, or 7:30, but the class is at 8. Because people who were like up and ready, she's like, I'll give y'all the opportunity to take it earlier if you would like. So it depends on how you feel about it. And Or also said that we probably should get started actually on class. So we'll do this in discussion. I'll copy and paste everything.
Okay. Well, if you have more ideas on this in this regard, just put it in discussion, and maybe we can continue the discussion in the discussion section of Canvas. Yeah, because guys, this is the first time for me to teach through Zoom, or teach through Canvas as well. So I value your feedback, and I know that you all worried. You all want to make sure that if you're an honest student, you want to make sure that everybody else adheres to the safety code, correct? So and whatever you feel is best, just let me know. All right, any more? Yep, put this stuff in the discussion. Okay, somebody really wants to go over the new material. All right, chapter 6, new material. So we're gonna hit the enzymes. So the enzymes are very important biological molecules. Okay. Perform extremely important functions. And we'll have the whole chapter on those. Can you see my slides?
Yes.
All right. So let me actually throw this one slide in here. All right, so what are our goals here? All right, so we'll talk about physiological significance of enzymes. All right, so specifically what they do, what kind of functions they have, and what happens if they stop functioning, what happens if they are overactive. Then we'll talk about actually specifically how they catalyze reactions and why they catalyze reactions, right? So the origin of catalytic power. And we'll talk specifically about chemical mechanisms of catalysis, like what they do to catalyze the reactions. So why reactions are faster in the presence of enzymes. Then we'll specifically look at two enzymes, chymotrypsin and lysozyme, and the catalytic functions and the mechanisms they utilize in their reactions. And then finally, something which is the hardest part of this chapter and probably the hardest part of the entire course, because there's quite a bit of math there. Description of enzyme kinetics and inhibition. Well, I wouldn't say it's very hard. It's just that biochemistry in general is quite a descriptive course. But so this one is somewhat less descriptive. There are some precise math involved here, and it's not very difficult, but it's just less descriptive, something that you really need to understand and cannot memorize. So for enzymes, so let's write down a few things, a few points. Now, so let's do the title, enzymes. So just think about sugar, right? You have like right now I'm having coffee with sugar in it. Maybe I should be having coffee with an artificial sweetener. But I hate those things. Sugar plus oxygen. So in my sugar jar, where I get sugar for my coffee every morning, I have this sugar sitting in there for a month maybe, but then in the actual bag that I buy sugar maybe once every few months, and nothing happens to it. But but the reaction that you can envision, so the sugar can burn, right? So for example, glucose, the chemical formula of glucose is 6,6H12O6. Well, sugar by itself is not the glucose itself. It's the dimer of glucose and fructose. We will talk about that when we discuss carbohydrates. But glucose is a representative of sugar. So sugar is actually a general name for a variety of carbohydrates. So for example, this glucose, it can burn, and it can produce carbon dioxide and water. Extremely exergonic reaction. Plus lots of energy. How do we know that it has a lot of energy? Well, if you have small kids, or if you have witnessed somebody else's kids, give somebody a candy or a few candies, and the child who may have been sleepy or kind of dormant or whatever, dejected, all of a sudden this child starts jumping all over the place, is full of energy, starts getting into things, and the level of energy increases tremendously, right? So there is tremendous amount of energy released after you burn the sugar. But on a shelf, nothing happens. Nothing happens. My sugar sits there, even though there's plenty of oxygen in the air. there's no sign of decomposition, no sign of the conversion of this sugar into carbon dioxide and water, right? But in a cell, in the presence of a biological catalyst, this process takes minutes or seconds. This process takes seconds. So you can see tremendous rate acceleration by enzymes in simple reactions, right? So reactions by themselves can be exergonic, but it doesn't mean that they will proceed at a very fast rate. So let's see what else I want to say as far as the introduction. So that's one point I want you to make about the enzymes. The second point I want to make about the enzymes, just think about there are all these diseases. If there are so many genetic diseases which result from the lack of particular enzymes, right? So the particular enzymes, if they do not perform the right function, if the lack of them, then the person develops some kind of symptoms of some kind of disease. Just think of think of how liver functions, right? So liver, what enzymes are present in the liver? What's the main function of liver? Anybody knows?
To cleanse the toxins of the body.
Mm-hmm. So liver enzymes. Well, toxins, but also any kind of metabolism. So when we say metabolism, that means degradation, right? Metabolism. This could be degradation of toxins. This could be degradation of drugs, toxins, drugs, various endogenous molecules, metabolites. So when people say drug-drug interaction, you know, when you take a drug, right, and you're taking some other drug, you always have to consult your physician, or at least go to drugs.com and look for drug-drug interaction. What's the main issue with drug-drug interaction? Like where does it come from? Like what's the main cause of drug-drug interaction?
Is it the side reactions?
Well, side reactions where? And can you elaborate on that?
Like the side reactions in between like the drugs interacting lead to toxins in the body?
So you actually you actually mean between these two drugs, so a reaction between these two drugs.
I mean between the drugs and their like each drug and their reaction in the body, and then their side reactions cause toxins in the body, I guess.
Well, the drug concentration is very low in the bloodstream, so it's very unlikely that there will be a reaction between the drugs themselves or their metabolites, because the concentrations of all these pieces is going to be very low. But the main cause of drug-drug interaction is the suppression or overactivation of liver enzymes. Drug-drug interaction.
Repeat that one more time.
So drug-drug interaction. Drug-drug interaction comes from suppression, or let's say from the effect on liver enzymes. On liver enzymes. For example, you've heard of even here when we talk about drug-drug interaction, people think in terms of prescription drugs, but you guys probably heard of St. John's, how do you spell it? St. John's wort, right? Have you heard of that? Anybody?
No, what is that?
St. John's. It's a considered to be folk medicine for depression. Let me see how to spell it. I think it's word. Just 1 second. Did you know that Trump just got tested positive for coronavirus? I was just reading this on the news today.
It's WORT. If you're
WORT. So, right. So when people say about drug-drug interaction, they always think prescription drugs, and they think that these folk medicines are totally innocuous, and they're not. So St. John's wort, for example, has a tremendous effect on the expression of liver enzymes, which can mess up your the metabolism of the drugs that you take. So there's a tremendous possibility, there's tremendous chance that if you take St. John's wort for depression, thinking that it's just some kind of folk medicine like a multivitamin or something, and take some kind of drug, then the levels of the drug can be elevated in the blood tremendously. Let's say if the metabolism of the drug is suppressed. And then what happens? What happens if you, so normally when the drug is prescribed, and they say take 5 milligrams per day, why is it 5 milligrams? Because 5 milligrams has been determined to be the right dose because the metabolism of the drug in the liver has been taken into account, right? So in other words, from 5 milligrams, let's say 4 milligrams will be immediately metabolized in the liver, and the 1 milligram in the blood is the effective dose, right? And now imagine that your liver enzymes are not expressed anymore. St. John's wort stops that, right? And then 5 milligram of this drug, and none of it is metabolized. So instead of 1 milligram in the blood, you end up with 5 milligrams in the blood, which can build up to a toxic dose, right? So it's basically, for the most part, drug-drug interaction comes from the liver enzymes. And you can see the tremendous role of enzymes here as well, something that we really have to take into account because of something very practical, right? So these drugs, many of us take drugs and many of us take many drugs. And there's a crucial role of liver enzymes in here, and we really have to watch for that. All right, so this is just a little bit of significance for you to appreciate how important the enzymes are and how important it is to the knowledge of how enzymes work and how they perform their chemical reactions. So, and the third point I wanted to make here. Do you have any questions so far?
So would overdose, like on a drug, be like overwhelming your liver enzymes?
No, overdose, basically you build a toxic dose. You know, for each drug in the bloodstream, there is a dose at which the drug is ineffective. There is a dose which is called therapeutic dose, and there is a dose which is called toxic dose, right? So the toxic dose will just lead to bad side effects. And the reason for that is because the liver enzymes do not metabolize the drug.
Okay.
All right. The third point I wanted to make, there's this concept that we touched on in OCHEM 1 called vitalism. Anybody remembers what vitalism means? Vitalism. So there is a, in 1850s, a French chemist, Louis, very famous French chemist, Louis Pasteur. He studied basically the fermentation of sugar into alcohol. Studied sugar into alcohol in the presence of yeast, right? So yeast, basically it's a multicellular, so it's a eukaryotic organism, right? Where basically the enzymes are within the cells. They're not exposed. They're not exposed and not isolated by themselves. So and so he basically, this is one chemical, sugar. This is another chemical, sugar, right? And they're both biologically related, right? So sugar and alcohol are both biological molecules, and the reaction is performed by a biological organism. And so because of that, he derived the concept known as vitalism. So basically, in other words, basically he's saying that the biological reactions can only be performed by living organisms which have this specific component to them, like vitality, right, which is absent in non-living objects, right? So all living organisms have that in them, just like some kind of spirit, right? Spirit. And so this concept of vitalism actually was lasted for about 50 years until a scientist whose name was Buchner. Until Buchner in 1897 discovered that this reaction can be catalyzed by cell-free extracts from yeast. So cell-free means you break up the cell, and whatever's inside basically pours out of the because basically you break the cell membrane, right? And whatever's inside spills out of the cell, and then you do the extraction, right? So for example, many enzymes can be extracted, and you perform, and it turns out that these extracts can catalyze the same reaction. So you don't need a living organism for this reaction to occur. And so that was sort of the end, that I wouldn't say the very end, but that sort of started the process to end the concept of vitalism. Who do you think was in favor of vitalism? What layers of society?
Those who believed in biogenesis.
Well, how about Catholic Church, right? So over the years, so there's always been a big war between the scientific discoveries or scientists who postulated things that were not taught by the church or went against the church dogma, right? And so obviously vitalism was had a strong proponent in the as a in the face of the Catholic Church. So so that's why it lasted so long, even though there were a lot of smaller kind of experiments, kind of slowly chipping pieces away from it, but they were not strong enough to completely destroy the dogma. But this was one of the experiments that did. So you don't need a living organism with its own spirit to be able to perform a biological transformation. All right, any questions about any of this? All right. Sounds good. So what are enzymes? So enzymes are obviously catalysts, and they increase reaction rates without being used up. So we know that from general chemistry, right? That's what catalysts do. They're not being used up. They participate in reactions. They're consumed in the first step, and then they released in the last step, right? So for biological catalysts, most of these are globular proteins, right? And we also know that some RNA, so for example, ribozymes or ribosomal RNA, so these are enzymes which consist primarily of RNA. They also know to catalyze reactions. Now, when we study nucleic acids, you will see that the RNAs are not as efficient, primarily because how many nucleotides? Remember, guys, perhaps from biology, I don't know, we haven't really started working on nucleic acids yet, but how many nucleotides, how many nucleic bases is RNA composed of?
4.
4, that's right. So how much diversity is that? Not so much diversity, right? So basically RNA is a sequence of nucleotides based on 4 nucleic bases. Same with DNA, right? And so diversity is not as pronounced as it is with globular proteins. Globular proteins, so we have 20 amino acids. 20 amino acids, and this the huge amount of huge diversity in terms of how the primary sequence and the secondary sequence, tertiary, quaternary sequence, right? So the proteins can be much more selective. They can be quite much more specific for particular substrates just because of the variety of structures that they can adopt. So RNA cannot do that. Yeah, RNA as the enzymes. But even though there's the theory right now is that the original catalysts were molecules based on RNA. So there's even a concept known as RNA world. RNA world is when the living systems were based on catalysts that were derived from RNA itself. And then the living systems realized that actually proteins are much better at catalyzing reactions than the RNAs, right? And slowly the function of enzyme catalysis was basically adopted by proteins and lost by the RNAs. So the study of enzymatic processes is very old. People have been studying this for a long time, and it continues to do so, right? So we're still learning a lot about enzymes. We're still learning a lot about globular proteins, which function as enzymes. So here are some of the names of people who actually contributed tremendously to our understanding of how enzymes work, right? I think if you're interested in some history, you can look up these names, right? See what these people did. And so the question is, so we learned in general chemistry a lot about inorganic catalysis, right? So for example, even organic chemistry, right? So how do we do hydrogenation? So if you have an olefin or alkene and you want to add hydrogen gas, what catalyst would you use?
Water?
No.
Would it be palladium?
Palladium or nickel, remember, or any kind of metal, right? So these are inorganic catalysts. Inorganic catalysts, and remember the way they work is they, for example, with hydrogen, they break the hydrogen molecule into two constituent hydrogen atoms, right? They activate hydrogen this way. And so the question is, why would we want biocatalysis over inorganic catalysis? So why can't we just have these metals in biological systems that catalyze reactions? And in a way, that's actually correct. Many of these biocatalysts do have inorganic metals, do have metals in them that facilitate the catalysis. But the majority, the biggest portion of the catalyst itself is going to be the actual protein, which has some metal inside. So, and obviously, if you have a large molecule that catalyzes this reaction, a greater reaction specificity, right? Just imagine that if you have a larger molecule, you can incorporate so many amino acids, which will add to the specificity. It's just like, think of a lock and key, right? Even though we know there's lock and key is not, right now, it has been shown that lock and key is not the best theory for how these molecules work. But think about, let's say you have a key, right? And you have a lock. So the simplest lock would be a lock where basically you just have a hole, the key fits in, and there is no any additional features. You just put the key in. There is no particular details on the lock or on a key that would require for the key to fit in. You just put, like, let's say the key is a flat plate, right? You put it in, turn it, and the lock unlocks. So that would be totally unspecific lock, right? It basically will accept any kind of key with a flat blade or so. But then you start adding detail. Like your log will have let's say a groove on one side, no groove on the other side. It will have a bump on this side, no bump on that side. It will have some kind of invagination here, no invagination there, and so on and so forth. So you start adding the level of detail, and by doing so, fewer and fewer keys will fit into the log, right? And so obviously, as you increase the size of the enzyme, you can add all these features. The bigger the size, the more features you can add. And so that will increase the specificity of your log. That will increase the specificity of the biological catalyst. All right, I think we're out of time, so we'll stop at this point. We will start on Monday from this slide. Now, as far as the exam, so again, if you have more thoughts about how the first exam went, I encourage you to put it on the, you know what, I'll create right after this class, I'll create a topic, exam 1, on this in the discussion on Canvas. So place your thoughts there, and we'll go from there. If you don't have any questions, You all good? All right. So I'll see you Monday morning. Bright and early. Bye.